Okay, good morning, everybody. My name is Mr. Layode Ndoye. I'll be taking you physics this morning. Um, the subject we are going to be treating today is going to be called surface tension. Surface tension. We're going to be treating a topic called surface tension. So let me share my screen with you so that we can quickly go into it. Yes, this is it. Hello, students. Welcome to class. A subject physics. Like I said earlier on, I said the topic for today we're going to be treating what surface tension, and the objective of today is going to be at the end of the lesson. Students should be able to one define surface tension, number two state the effect of surface tension, and number three state ways of reducing surface tension. So we'll quickly look at the first objective, which is to define surface tension. To define surface tension. So let's quickly go to the next slide and look at what is surface tension. What is surface tension? Now I'm going to the next slide so that we can. Actually, I'm using Google Jamboard, so we'll look at it together. All right. This is it. I said, what is surface tension? That's the first objective that we have for today's class. So, what is surface tension? Surface tension is a force that exists on the surface of liquid, which makes the liquid behave as if it were covered by an elastic skin. What do we mean by that? We can see a diagram just very close to the definition of what surface tension is. We can see a diagram that describes what we are saying as the definition. Where we say that surface tension is a force per unit length. It's a force that exists on the surface of liquid. So the only place that this surface tension or the force can exist on the surface tension is only on a liquid. So if you look at the diagram I have here, you can see a needle that is slightly placed on a surface of water. That is slightly placed on the surface of water. So you can see that's what makes it looks like as if the water, as if the liquid behave um, like an elastic skin. So that alone is a very good illustration. A needle that is placed on a surface of water. So you can see the direction, the arrows I have here. You can see the surface tension, you can see the needle, you can see how the surface tension is going backward, and you can see the gravity. The gravity. So the what makes the needle to stay on the water is due to what? The surface tension. The force that exists on the surface of the liquid makes the needle to float on the water. So that is just a simple illustration of the surface tension, the diagram, and then the definition. You need to digest the definition as a physics student. You need to digest that definition. Very simple definition with the illustration I've described to you. You can as well keep this in your memory. Surface tension is a force that exists on the surface of liquid, which makes the liquid behave as if it were covered by an elastic skin. So the next objective after the definition is the effect of surface tension. So we go to our third slide, and then we look at the effect of surface tension. Effect of surface tension. Now we have some factors affecting surface tension. Number one is temperature. Number two is a solute. What do we mean by solute? Solutes can have different effects on surface tension depending on their structure. little or no effect. For example, sugar, for example, increases the surface tension in water. When you put sugar into water, it what? It increases the surface tension. Now, inorganic salt decreases it. So we're still going to be looking at ways of reducing surface tension. The ways of reducing surface tension. So if you look at this now, you can see we said sugar increases surface tension, while inorganic salt decreases surface tension progressively. Alcohol too decreases surface tension. When you boil a water, it decreases the surface tension. And once a minimum is reached, no more effect. No more effect. So if you look at what we have here, the surface tension here, I'm going to ask a few questions. I'm going to ask, what happens here? He said, Bugs is walking on water. Why is this possible? Is a question I want you to go with. Bugs that walks on water. Why is this possible? It doesn't weigh much. It's spreading its weight out. Then the downward force are less than the effect of surface tension. This is the reason why a bug will walk on water. It doesn't have weight that much. It spreads its weight out. Then the downward force are less than the effect of surface tension. The downward force are less than the effect of surface tension. So that is an effect of surface tension there. We still have more examples of effect of surface tension. We have a dry needle can float on still water when gently placed on it. We've talked about that when I showed you the illustration while defining surface tension. So lastly, we'll look at ways in which we can reduce surface tension. How can we reduce surface tension? There's something we call soap is surfactant. That is surface active agent. Now here I have it that surfactant acts to reduce surface tension. We have so many surfactants that can reduce surface tension, but soap is one of them. Now, get between water molecules at the surface, reduce cohesion of water molecules. Now, when you put a soap into a water, it reduces the surface tension. That is, it gets between water molecules at the surface, reduces the cohesion of water molecules. Now, we also can add impurities, generally known as surfactants. So soap is one of the surfactants that we use in reducing surface tension. We can use oil to reduce it, and so on and so forth. So I'm going to leave you with this, the ways of which we can reduce surface tension. We've talked about the effect of surface tension. We've talked about what is surface tension, and then that is all about surface tension. So we can do a quick recap and just quickly look at the definition. What is the definition? We say surface tension is a force that exists on the surface of liquid which makes the liquid behave as if it were covered by an elastic skin. So if I'm going to give you an assessment to do, I'm going to ask you to give me an example. Give me an example of the effect of surface tension. More examples. Maybe you can give me like three. Sometimes I always tell my students, I said, Jesus walking on water was due to surface tension. Jesus walking on water was due to surface tension. That is what I normally tell my students, but that was a miracle on its own. So you can also look at that as an example. That is how I delve into it. Then you can ask, you can also um, give me more examples on your own as examples of effect of surface tension. Then I can also give you what you can also do on the application of the effect. How does it apply? What is the uses? That's the meaning of application of effect of surface tension. It's also part of the examples of uh, surface tension itself. It's also part of the examples of surface tension. Then I would like you to also give me more uh, surfactant, um, more surfactant that we can add to reduce surface tension. More surfactants that we can add to reduce surface tension. Now, if you look at this, you can see what I have here, that detergent molecules lining the water surface in the beaker. Other detergent molecules form clumps in the bulk of the water. So when you add the soap into a water, the when you mix it up very well, especially when you add a detergent to a water, when you mix it up very well, you will see the film on the surface of the water. Why that film is there is due to what? Surface tension. Is due to surface tension. So I'll just leave you with this, and then I want you to go ahead and do the needful. Digest what is surface tension, the effect, and the ways of reducing surface tension. Thank you very much. As we end the class. Bá mi palẹ̀kùn dé, má jẹ́ kí n sọ nǹkan tí mi ò fẹ́ ṣe lọ.